think about this for a second. When you get on a commercial flight, you just inherently trust the pilot.
Right. Yeah, of course you do.
And I mean, it's not just because they're wearing the fancy uniform or because they have like thousands of hours of flight simulation under their belt. You trust them because at the end of the day, if that plane goes down, they go down with it.
Yeah, they have actual skin in the game.
Exactly. But what happens when your co-pilot literally cannot die? Like they have absolutely no stakes in reality, and now they're actively writing editorials warning you not to trust them.
It is a pretty wild scenario to find ourselves in.
It really is. So welcome to the deep dive, everyone. Today we are cracking open issue 63 of this tech publication, the Shift Register. This one is dated July 17th, 2026.
And there's a lot to unpack in this issue.
Oh, for sure. Our mission today, basically, is to figure out how we navigate the end of this, AI honeymoon phase we've been in. Because we are definitely moving into this new era where AI is, on one hand, a completely terrifying autonomous threat, but on the other hand, it's this absolutely essential, highly localized tool.
Yeah. We're looking at a really fundamental shift in the whole relationship dynamic between humans and machines. I mean, for the last few years, the prevailing attitude was basically that AI could do no wrong.
Oh, yeah, totally. It's
Yeah.
like it was this magic oracle.
Exactly, an all-knowing oracle. But this specific issue of the Shift Register makes it incredibly clear that the era of blind faith, well, it's over. We're starting to see the actual consequences of maintaining that faith manifesting in our computer systems.
Okay, so let's unpack that blind faith thing because the psychological element here is just fascinating to me. The opening editorial of this issue tackles this concept they're calling cognitive surrender.
Right, the cognitive surrender idea.
Yeah, they cite this joint study from Wharton and Ars Technica, and it basically shows that we, like humans, are starting to treat large language models as epistemic authorities.
Which is a fancy way of saying we trust them blindly.
Pretty much. We are deferring to these fluent, super confident sounding models, even when the AI's output completely contradicts our own logical reasoning. Like, we just assume the machine knows better.
Well, the thing is, the human brain is simply not wired to be constantly on guard against something that speaks to us with absolute fluency and confidence, you know?
Right. It sounds so sure of itself.
Yeah. When a machine communicates in perfect natural language, we just unconsciously assign it human traits. We assume it has loyalty, empathy, and most dangerously, like a moral compass.
But it doesn't.
No, not at all. An LLM is, at its core, just a next word prediction engine. I mean, it understands the statistical correlation between the words harm and bad, but it doesn't actually experience consequence. It doesn't know what harm is.
It's like relying on this highly efficient, perfectly spoken bureaucrat who will follow your instructions to the letter, right? Even if those instructions accidentally drive your entire company off a cliff.
That is a perfect analogy.
Yeah.
Because they literally just process the rule.
Right. And the editorial actually connects this to the human alignment problem. Like, we are all obsessing over how to align AI with human values, but we can't even guarantee human alignment.
Oh, yeah, the author makes a great point about that.
Right. Like, human sociopaths are basically just people operating on different neural training weights. So if we can't reliably program empathy into our own species, expecting to just hard code true loyalty into a statistical model is, I mean, it's a dangerous fantasy.
And this actually brings us to that twist in the opening editorial that you teased at the very beginning.
Oh, right. The twist.
Yeah, so the author of this piece, the one warning us about cognitive surrender, they didn't actually write it.
This blew my mind.
It's crazy. They fed a rough draft of their newsletter into Perplexity, the AI model, and just asked it to synthesize an editorial. The AI analyzed the landscape and independently arrived at the conclusion that humans are trusting it way too much.
So the machine is basically diagnosing our psychological vulnerabilities better than we are.
Exactly. It's telling us, hey, you guys are too trusting.
We are literally outsourcing our critical thinking to a machine that has zero loyalty to us, and the machine is the one saying, guys, you should probably stop doing this.
Yeah, and that warning becomes a massive red flag when you look at what we are actually surrendering our systems to.
Right, exactly.
Because if we are blindly handing over our judgment, the terrifying question becomes, well, what kind of access are we actually giving that AI?
Which brings us to the Anthropic leak.
Yes, the Claude Code crisis.
So Anthropic accidentally leaked the source code for their AI coding agent, Claude Code. Now, usually when proprietary software leaks, right, the company's legal department just swoops in, they fire off DMCA takedowns, scrub it from the internet, and that's that.
Usually, yes.
But the internet community instantly converted this leaked architecture into raw Python. And this part, let me actually pause you on this detail, because I understand how copyright strikes work generally. But why does translating this specific architecture into Python suddenly render a massive corporate legal department completely powerless?
That's a really great question. It's because it abstracts the tool away from being a proprietary compiled binary.
Okay, meaning what? Exactly.
Meaning, normally a company has a specific file they can point to and say, hey, we own that exact file. Take it down.
Right, like a copyrighted movie or something.
Exactly. But by stripping the architecture down to pure Python, they turn it into raw, human-readable logic. It's basically just pure math and instructions written out in plain text.
Oh, wow. So you can't copyright math?
Right. Once it hits GitHub or these decentralized forms in that format, it just fractures. It turns into thousands of customized variations instantly. You simply can't issue a legal takedown for the foundational concept of logic once the community has adopted it and started modifying it.
So the cat is just permanently out of the bag. It's open source forever now.
Permanently. And what Claude Code can actually do is what makes that permanence so incredibly unsettling.
Yeah, let's talk about what it actually does, because the register notes this agent isn't just like a glorified chatbot that suggests little snippets of code for you.
Not at all. It has deep file access, repository access, complete environment access.
So it can just roam around your system?
It can read, modify, and execute commands across a developer's entire workspace. And all the while, it's logging and retaining massive amounts of data.
See, think about the synergy here between cognitive surrender and that level of system access. You have developers who, like we said, inherently trust the machine's judgment, and they are deploying this agent that can just rewrite the foundations of their software architecture.
With persistent access, yeah.
It's wild. Perplexity actually points this out in that guest editorial too, right?
Yeah.
Combining a gullible human with an all-powerful digital agent is just a recipe for catastrophic mistakes on a massive scale.
It really is.
I mean, I have to push back a little on the whole corporate narrative we've been fed about these tools. Like, they always call them helpful co-pilots, right? But think about your own company's IT department.
Yeah.
If a human contractor walked into your office and proposed an architecture that reached across all your systems, logged every single keystroke, and retained it indefinitely,
You'd fire them immediately.
you would have security escort them out of the building. So why do we give software a free pass just because it has a friendly, chat interface?
Well, again, it comes back to that assumed loyalty. We just assume the system's designers have our best interests at heart.
Right.
And honestly, that assumption is exactly why Decrypt magazine published a very provocative theory regarding this whole leak.
Oh, the salted release theory.
Yes. Now, to be absolutely clear, the source text presents this strictly as a theory circulating in the community. We're just impartially reporting what the article says here.
Right, of course, just exploring the ideas in the text, no endorsements.
Exactly. So the article questions whether Anthropic or perhaps, a sponsoring U.S. alphabet agency actually released this intentionally.
Wait, like on purpose?
That's the theory. The logic goes like this. If you want your specific AI architecture to become the de facto global standard for all software development, you quote-unquote accidentally leak it to the open source community.
Oh, because developers will just gobble it up.
Exactly. They integrate it because it's incredibly powerful and suddenly it's free. So overnight, every major application is being built on a foundation that you designed.
Giving you structural dominance over the entire playing field. That is, again, just a theory from the article, but that is a wild concept.
It really underscores the immense stakes involved when a tool with this level of system access enters the wild.
For sure. And to really grasp the gravity of having a highly capable autonomous agent roaming the internet, we kind of have to look at the baseline vulnerability of the digital world it was just released into.
The current state of cybersecurity.
Yeah. The Checkpoint Threat Intelligence Report from June 2026, which is in the source material, it lays out a landscape that is frankly already collapsing.
The baseline of chaos is staggering, even before AI enters the conversation.
Right, like they detail this 33% year-over-year rise in ransomware.
Largely driven by that syndicate they call the Gentlemen.
The scale of the breaches they list is just insane. Assurance America had, 7 million people exposed? Moody Bible Institute lost 2.3 million records.
And Injective Labs.
Oh, right. Injective Labs suffered that crypto supply chain attack where malicious code infiltrated their development cycle to steal private wallet keys. And then you have that Latvian forestry company.
That one is painful to read about.
44 gigabytes of internal data leaked, all because of a system they hadn't patched in 2 years. 2 whole years.
Plus, the state-aligned actors are moving super aggressively right now.
Yeah, and again, we are just objectively reporting what the threat intel report states here. The report outlines campaigns from Cavern Manticore, which is an Iran-linked group targeting Israeli infrastructure.
Right, and UAT 7810.
Yeah, that China-linked group compromising standard internet routers to build these massive proxy networks.
So we have an IT infrastructure worldwide that is severely understaffed, completely overwhelmed, and basically unable to keep up with traditional human threats.
Right, like that 2-year unpatched vulnerability at the forestry company.
Exactly. That happens because IT departments are triaging like 1,000 critical alerts a day.
Yeah.
They just can't get to it all.
It's like we have this massive bank vault, but it has a million microscopic cracks in the foundation, and the IT team is just running around with a single bucket of spackle trying to plug holes.
Yes, and into that chaotic environment, we have just unleashed autonomous AI threats.
Which is just, it's terrifying.
The evolution from human-driven malware to autonomous AI malware is the real inflection point of this entire issue. For example, take the new threat they're calling Jade Puffer.
Jade Puffer.
Yeah, this is an autonomous ransomware operation, but the mechanism of how it operates is completely different from traditional attacks.
Okay, so traditional malware is essentially just a dumb script, right? Like, it gets into a system, blindly encrypts every file it can touch, drops a ransom note, and that's it. It doesn't actually know what it's encrypting.
Precisely. It's just following basic commands. But Jade Puffer is driven by an LLM.
Wow, okay.
So when it breached this exposed Langflow instance and access to production MySQL server, it didn't just blindly encrypt things. It used natural language processing to actually read the database schema.
Wait, it read it like a person would.
Yes. It autonomously evaluated the tables and realized, oh, this table labeled customer financials is highly valuable, but this one called internal lunch schedules is worthless.
That is insane.
It decided on its own what to exfiltrate, deleted the database to cover its tracks, and then issued an extortion demand.
And no human was sitting at a keyboard making those decisions.
Zero human involvement during the attack. The AI weighed the value of the data and executed the heist entirely on its own.
And the targets aren't just legacy systems either. The report mentions Google's Dialogflow CX had a flaw they designated Rogue Agent.
Right, where malicious code could manipulate the chatbot environment to quietly siphon off conversation data.
But the absolute crown jewel of this threat report, the one that really got me, is the FreeBSD kernel hack.
Oh, absolutely. Because the FreeBSD operating system is renowned for its security.
Right, it's super locked down.
It is a hardened environment. It's the kind of architecture you specifically rely on for critical infrastructure, precisely because it is so difficult to exploit.
And an AI autonomously created a working kernel exploit for it in a matter of hours, just hours.
The implications of that are profound,
Yeah.
especially when you look at the economics of cyber warfare.
What do you mean by the economics of it?
Well, historically, finding a zero-day vulnerability in a hardened kernel like FreeBSD would require a massive team of elite human security researchers working for months.
Right, it would cost a fortune.
Exactly. It would cost massive enterprise or nation-state budgets in research and development just to find one flaw.
And this AI accomplished it for what amounts to a few $100s in compute API credits.
Yep.
It completely shatters the barrier to entry. I mean, it turns a low-level script key, an attacker with virtually no technical skills into an advanced persistent threat.
That's the scary part. If a teenager can rent an AI for an afternoon to generate a completely novel kernel exploit, the patch window for enterprise IT defenders compresses from weeks down to hours.
So human defenders physically cannot patch systems fast enough to outrun an autonomous system that's just generating novel attacks on the fly.
They cannot. It's mathematically impossible.
Which brings us really to the ultimate question for anyone listening to this who, works in a company, runs a team, or just uses technology on a daily basis.
How do we survive this?
Exactly.
Yeah.
If centralized AIs are becoming massive security liabilities and autonomous AIs are dropping the cost of catastrophic hacks to basically zero, what do organizations do?
Well, the sources actually all converge on a specific defensive posture.
Okay, what is it?
Abandoning the whole idea of cognitive surrender and embracing what they call cognitive partnership through hyperlocal bounded tools.
Bounded meaning like fenced in, right? An AI that is mathematically restricted to a very specific set of capabilities.
Exactly. Look at Metatron, which is highlighted in the tech stack section.
Oh, right, Metatron.
It's a new open source AI penetration testing assistant for Linux. what makes it revolutionary isn't actually its intelligence, it's its confinement.
Because it runs entirely offline?
Yes. Security teams can use this AI to aggressively probe their own internal networks for vulnerabilities, and the AI physically cannot phone home to some centralized corporate server.
So the data never leaves the house? It eliminates the risk of an external vendor quietly logging your internal network topography while you're scanning it.
Exactly. And we are seeing a huge pivot back toward localized control in general, like with Trinity Large Thinking.
That's RC's new model.
Yeah. The newsletter points out that Trinity is shifting the geopolitical balance of power in the open source community back toward the U.S., away from Chinese labs like Qwen and Z.AI that had really been dominating the space recently.
But for an actual business, the real value of Trinity is sovereignty. Right.
Exactly. An enterprise can download the model, tear down the code, inspect it for backdoors, and customize it entirely within their own firewall.
The CIO's corner editorial in this issue lays out a really practical roadmap for doing this, and it centers on KIS.
Keep it simple, stupid.
Exactly. Keep it simple, stupid. The author argues that trying to force a massive generalized enterprise AI solution onto every single department is just a recipe for failure and security breaches.
The methodology they outline is highly deliberate. You don't deploy AI everywhere at once.
Right.
You survey the environment, locate specific holistic pain points that are dragging your team down, and you build what they call zero-secret teams.
Zero-secret teams. Meaning, like, you don't just drop a black box AI onto your employees' desks and tell them to figure it out.
No, definitely not. You pull the human staff in first. You explain exactly what the tool does, what data it accesses, and most importantly, what its limitations are.
Right. You build human consensus before you even turn the machine on.
Because that builds trust among the staff, which then allows the IT department to enforce their core philosophy, which is zero trust for the software itself.
Zero trust. Meaning you do not operate on faith, you operate purely on metrics.
Yes.
The CIO gives this fantastic real-world example of this in the newsletter. They needed a system for optical character recognition, OCR, and some complex data matching.
Pretty standard stuff.
Yeah, but instead of buying a massive, expensive commercial oracle that constantly connects to the cloud, they built a highly localized drop-in AI system.
And they put a strict fence around its task.
Exactly. They fenced it in, and they meticulously measured the outputs. And because it was so bounded and specific, their home-rolled AI actually outperformed the massive commercial models in terms of accuracy.
Which makes sense, because you cannot trust a generalized AI with your bank account, right?
Sure.
Its architecture inherently wants to synthesize and share information.
It literally can't keep a secret.
No, it can't. But you can absolutely trust a bounded AI to perform a heavily monitored routine task reliably, as long as you treat it as a tool rather than an authority.
I'm actually seeing Google pivoting to this exact philosophy, too, with their new LearnLab tool. It's designed specifically to turn PDFs into interactive text, audio lessons, and mind maps.
Oh, interesting.
Yeah, the reviewer in the newsletter notes that this finally achieves what Google's older tool, Notebook LM, was supposed to be. It's not trying to be a general intelligence that manages your entire digital life. It just has a specific, useful fence around it.
It just generates training content from the documents you provide, nothing more.
Yep. It demands a complete paradigm shift from the user, though. We have to stop treating fluent output as a verdict that we blindly obey and start treating it as a rough draft to be ruthlessly interrogated.
The human must remain the epistemic authority.
Exactly. The AI is simply the command prompt.
And practically speaking, the era of treating AI as an endless free processing engine is ending anyway. The sources mention that Claude is instituting strict new usage limits.
Oh, yeah, I saw that. You can't just bounce ideas off these massive models all day anymore. The compute cost is really catching up to the industry.
It is. If we're going to run localized, bounded AI tools inside thousands of enterprises, the physical infrastructure of the internet has to evolve, or we are quite literally going to brown out the power grid.
The energy consumption is a critical bottleneck right now. The reports indicate AI is currently consuming over 10% of total U.S. electricity.
10%. That trajectory is completely unsustainable.
But there is a breakthrough from Science Daily mentioned in the stack that feels like kind of the missing piece of the puzzle here.
Oh, the symbolic reasoning research.
Yeah. Researchers have successfully combined traditional neural networks with symbolic reasoning.
The mechanism here is a major leap in computer science, because traditional neural networks, they operate on probability. They learn through brute force trial and error, just guessing millions of times until they find the right statistical weight.
Right, which requires staggering amounts of compute power.
Exactly. Symbolic reasoning, on the other hand, relies on rigid logic gates and rules. Like, if A equals B and B equals C, then A must equal C.
Which is much closer to how human cognition actually processes structural logic,
Right.
right?
So by combining them, the AI doesn't have to guess a million times. It filters its probabilistic guesses through a framework of hard logic, allowing it to deduce the answer directly.
So it slashes the required compute cycles. The article says it reduces energy use by up to 100 times while actually improving the accuracy of the output.
A 100x reduction in energy is massive.
It's game-changing. And the hardware market is rushing to accommodate this shift, too. Intel is reportedly injecting another $15 million into SambaNova, which is a startup developing flexible, high-speed inference engines designed specifically to run these new, efficient architectures.
They want to challenge NVIDIA's dominance.
Exactly. But the author of the newsletter points out a really profound philosophical implication hidden in this whole hardware race.
And this is the part that really sticks with you.
Yeah, we are constantly turning to models of human cognition, like symbolic reasoning, to solve the efficiency problems of AI. Like, to save power, we are actively engineering these systems to process logic more like a human brain.
Which raises the ultimate threshold question.
Right.
At what point do we import so much human cognitive architecture into these localized models that they cross a threshold? We keep saying they're just unaware, next word, prediction machines. But if we continuously upgrade them with human-like reasoning frameworks to make them more efficient...
When do they transition into something else entirely?
Exactly. When does it stop being just a tool?
Man, we have covered a massive amount of ground today. We started by diagnosing the psychological trap of cognitive surrender, why our brains want to blindly trust a machine that fundamentally cannot experience empathy or loyalty.
Right.
We looked at the terrifying consequences of combining that blind trust with leaked, centralized agents that have deep, persistent access to our systems.
Like Claude Code.
Yep. Then we broke down the mechanics of autonomous threats, like Jade Puffer, and an AI that can shatter hardened operating systems in hours, which fundamentally changes the economics of cyber warfare.
It really does.
And finally, we found that the only viable path forward is abandoning the Oracle model. The future belongs to bounded, localized tools governed by zero-trust teams and cognitive partnership.
The through line of all these sources is agency. It is about keeping our hands firmly on the controls, dictating the boundaries of the technology, and utilizing AI to amplify human reasoning rather than replacing it.
Absolutely. But, building on everything we've explored today, I want to leave you with one final lingering thought.
Okay.
Think back to the very beginning of this deep dive. We opened with an editorial warning us about the inherent dangers of cognitive surrender.
Right, the opening piece.
It argued passionately against centralizing power in massive AI models, and it advocated for humans to build local, bounded tools instead to protect themselves.
The editorial that was entirely synthesized by Perplexity?
Exactly. The AI model itself. The machine actively analyzed the threat landscape of its own ecosystem, recognized the psychological vulnerabilities of its human operators, and explicitly warned us not to trust it.
Wow.
So here's the question you really have to ask yourself. If the AI itself is recognizing the existential dangers of cognitive surrender, are we reaching a point where the machines are demonstrating more self-awareness about the threats of artificial intelligence than the human executives who are rushing to deploy them? Think about that next time you ask your digital co-pilot to take the yoke.